Hello everyone, Mr. John here from Areteem Institute with this week's Thursday tidbit, which is going to be Vieta's formula for quadratics. Now, we've done some stuff with quadratics before, but Vieta's formulas are a little bit of an extension of some of those earlier things too. To remind us of what we've covered before, I'll link the video below for the discriminant. We talked a little bit about the quadratic formula, right? This portion underneath the square root, right? But the general idea is if you have a quadratic equation with coefficients a, b, and c, those are going to play a big role today, you can determine the roots with the quadratic formula. What does Vieta's theorem say? Vieta's theorem is specifically talking about some relationships between the two roots. So you can, of course, find the two roots using the quadratic equation and the quadratic formula. But today we're going to see how, depending on the problem, you can do some shortcuts with these relationships. So if you focus on a, b, and c, these coefficients, we have our two roots of the equation, r and s. And these things are pretty easy to prove using the quadratic formula. If you add up the two roots, r plus s, you get negative b over a. And if you multiply the two roots, r times s, you get c over a. So you can just write this out using the quadratic formula, add them together, negative b over a, multiply them, you get c over a. And the point here then is there are certain scenarios where knowing the sum or the product can help you solve a problem. And you don't actually need to solve the full quadratic equation. That's the whole point of Vieta's formulas and how we can apply them to problems. So let's look at one of the common types of questions that comes up when we're talking about Vieta's formulas and quadratics. So we read the question here. They say, what is the sum of the squares of the roots of this equation? 2x squared plus 5x minus 4 equals 0. Now, sum of the squares, right? We're going to write this. Let me write this on the bottom, right? Our goal is to find r squared plus s squared, where we have our two roots in this case. We could, of course, solve the equation. This actually has quite messy roots. We could find it. There's two real roots, but they involve square roots and stuff like that there. So we want to see if Vieta's theorem can provide a little bit of a shortcut, and it can. So if we look at Vieta's formulas, remember this gives us a relationship between the sum of the roots. So the sum of the roots is negative b over a. And it tells us about the product of the roots. So rs, that is c over a. And remember, we're looking always at the coefficients. So we have our a value is 2, our b value is 5, and our c value is negative 4. Be a little careful with those negatives in those cases. So whatever the two roots are, we don't need to find them exactly, but we know their sum, r plus s, is negative b over a. So this is negative 5 halves. That is our sum of the roots. And our product of the roots is c over a. And so this is going to be negative 4 over 2. So this is going to be negative 2 in that case. Now, you might be thinking here, how does this help us out, right? How does this work for finding r squared plus s squared? Well, if we look at some squares, right? So for example here, what happens if we calculate, let's look at r plus s squared. So we can, let me box our Vieta's formulas here. This is the relationships we're going to use. So looking at that expression, well, you pretty easily could say r plus s quantity squared. Well, that is negative 5 halves squared. So this is just going to be equal to 25 over 4. So 25 fourths is the square of the sum. Note this is not equal to the sum of the squares, right? Because remember, this is equal to r squared plus 2rs plus s squared. So it's not quite what we're looking for there. But wait a second. The 2rs, that is actually our product, right? So we see our product showing up here. And so this is a very, very common relationship for these Vietas theorems problems. We can actually write r squared plus s squared. Well, it's not quite equal to the quantity r plus s squared because we have this extra 2rs, so we need to subtract that off in this case. So we have the quantity r plus s squared minus 2 times the product. So the sum of the squares is the, right, sum squared. So that is, we've already calculated 25 over 4. And then minus 2 times the product. So the product is negative 2. We had calculated that with Vieta's theorem as well. So we have 25 over 4 plus 4. So this is plus 16 fourths. And so our final answer is 41 fourths in this case. So we've now kind of done a little bit of a shortcut for calculating the sum of the squares in this scenario. So this is our kind of final answer here, our sum of the squares in this case. Thank you guys all for watching this video. Check back each Thursday for a new math tidbit in 2021. And be sure to check out the ZIML site or the ZIML mobile app for free daily practice and other resources as well. Goodbye.